Hello, this is Samir Rao, the student of Faculty of Engineering and Information Technology UTS. Today I am going to presentation on analysis of 5S model subjected to a Northridge earthquake for the structural dynamics and earthquake engineering. Let's get started. At first, I am going to talking about the background. Our building is two-dimensional frame to identify the dynamic properties. The calculation is based on multi-degree of freedom system for the dynamic loading. Our research includes for the calculation of 5S building model subjected to a Northridge earthquake. There are main three tasks involved, which are the calculation of dynamic properties in terms of natural frequency and mode shapes, and the comparison of the results by the exact method and the Holdzer method. And the major second task involves calculation of response spectra, and the performance of the building is checked through Australian code for the improved performance design. For the third task, major task involves improved shape design. If our design is failed due to the earthquake loading, then we have to redesign our building as per the Australian codes. Talking of the building information and geometry, our model structure and graphical representation is shown here. As you can see, our building is 5-story model, as you can see here. Talking about the building's geometry and material properties, we use the material properties of floor as a block, which is composed of mild steel, and the corresponding modulus of elasticity and density is given, and the building geometry is given here. After the calculation from the exact method, we found the natural frequency of omega 1 is 73.7457, and the corresponding time period is calculated, which means natural frequency is increases from the mode 1 to mode 5, and but the time period it decreases from the mode 1 to mode 5. And the calculation of dynamic properties, which is called mode shapes, by the exact method, which is shown below. For the first mode, the only translation is seen for the first mode, and the corresponding value of mode shape is here. And for the mode second, there is one translation at the joint, and the corresponding mode values are shown. And it is for mode 5, as you can see, joint 1, 2, 3, 4, 5, which is called mode shape 5 because there are 5 joints. And talking about the calculation of natural frequency and mode shape by the Holdzer method, as you can see here, for the mode shape 1, we did the trial of 2, and we get the trial after trial, and we get the natural frequency of 73.688, and the corresponding mode shape's value is here, and the corresponding figures is here. For the mode shape 2, and the omega is 215.045, which is similar to the mode shape obtained from the exact method, but little bit different. As you can see here, this is the mode shape 2, and this is the mode shape 3, and this is the mode shape 4, and the corresponding value of mode shape value is obtained here. Because we did the 2 trial, then we get the value at nearly 0 at the end, and we get the corresponding natural frequency, and it's the mode shape 5, as you can see here. Finally, the comparison of results by the exact method and the Holdzer method is shown here. For the exact method, natural frequency of omega 1 is 73.7457 radian per second, whereas for the Holdzer method, the omega 1 is 73.68, which is slightly different. As you can see here, omega 1 to omega 5, which is slightly different from natural exact method to Holdzer method. The natural frequency by the Holdzer method are not exactly the same to those obtained from the Eigen value program. This forms evidence that Holdzer method is approximate method, as we use as a Holdzer as an approximate method. In contrast, we can conclude each frequency of the mode shape independently obtained by the Holdzer method. However, the mode shape obtained from the exact method and Holdzer method are same. For the calculation of response spectra, we use the Duhamel integration formula to produce the overall response of the building, which is 5F, due to the Northridge earthquake loading, which is uses the ground acceleration obtained from the Northridge earthquake loading, which is given in the questions. And this is the displacement response factor for the different damping, is we have assigned to the 5% damping, 10% damping, 20% damping. For the maximum response for the different damping, let's say 0% damping. For the first mode, maximum response is 7.6 mm. As you can see here, for the fifth mode, maximum response is 0.4c, which is decreases for the increasing the mode safe. Talking about the seismic safe design, we use the code of 1170.4. To check whether the building is safe or not, we use the check the following different parameters such as drift, story shear, torsion, mass participation ratio, building time period, which have to pass according to the code, which is 1170.4. For the calculation of drift check or check for the drift, code provision to ensure the safety for the drift check shall not exceed 1.5% of the story height. Our case building model is 5s, height of the story is 50 mm. Drift provision is 1.5% of 50, because 50 is our height of the story, which is 0.75. In that case, our building is safe in drift check, which means as per our model, the total drift will not exceed 0.75 mm. If the model is failed in the drift, we must have to resist the drift by providing the strip of the column or overall strip of the building. For the torsion check, generally torsion comes due to the difference in mass of rigidity and center of gravity. And according to the Australian code 1170.4, for each required direction of earthquake action, EQX and EQY are the direction of earthquake, which is in x direction and y direction, shall be applied at the position calculated plus minus 0.1 b from the nominal center of mass, where b is the plan dimension. Talking about the response displacement at each floor, it is the value which is obtained from the Matlab code. At the top floor, we find the response or displacement, overall displacement of the top floor, which is 0.00551, which is 5.5 mm UD, which is obtained from the Matlab code. And this is the lateral force, which is obtained from the Matlab code. The maximum force is obtained is which is 44.36, as you can see here. For the model response from the Matlab, as you can see here, this is the ground acceleration of Northridge earthquake, and this is the displacement or for the mode safe one. As you can see here, this is I have gone through this Matlab code. As you can see here, when the acceleration ground motion starts, then our building model is start to vibrate. For the first mode, as you can see here, it is the model response from the ETABS, which I have models in the ETABS. And which is period is 0.013. As you can see here, this is the model 5, mode 5. It is the overall vibration or mode safe of mode 5, with the period is 0.0013, which is obtained from the ETABS software, and our value is close to 0.012, which is close to 0. After round of 0.013, and the value, it is the value which is obtained from the exact method.